I'm Magnus. In my previous video, I showed the basics of creating containers, and we ended up with a SQL Server container, which we could log into. All good. Today, we'll talk about building our own images that we can use to create containers. And I'm going to start showing inside Docker Desktop what a container image looks like, what the layers are. And then we will look at Docker files to see how we can create our own images. So on this screen, I have Docker Desktop for Windows. And then we're looking at a SQL Server 2022 container image, the one that we can get from the Microsoft Container Registry. So Docker Desktop is showing more than just the layers of the image. It actually shows if we have any vulnerabilities, known vulnerabilities in any of the images, and this could be pretty useful for security reasons, of course, to see if you want to start using a new image. Is that safe? Is it not safe? Etc. etc. So the base of this of the SQL Server 2022 image seems to be an Ubuntu 2004, and it has one layer that contains a vulnerability, and we can look it up by just clicking the link for the CVE here. I think, or I would assume, that a later layer in the image contains some kind of patch for that, or it could also be that that vulnerability is not exploitable when running just SQL Server. So I don't know really, I haven't analyzed it. That's not the topic. The topic is, what are the layers? So looking at the images, I've clicked on let me just find it. SQL Server 2022. We see it has an image hierarchy, which starts with Ubuntu 2004. And then the final step, or the final result, is the 2022 latest SQL Server image. And the layers, they're nothing else than directives in a Dockerfile. So you create an image by creating a Dockerfile, and then you ask Docker to build an image from that Dockerfile. And that Dockerfile will contain some directives, like a from directive. Start with a base image, which is this one. That's what you enter in the from directive. And then you can run some commands, you can set some variables, you can define build arguments in the Dockerfile. You can, what's done here, you can expose a certain TCP port, 1433. You can set environment variables. And what you would typically do probably also is to copy stuff from wherever you're building it into the container image. So in this case, this step, which is a copy that adds 1.35 gigabytes to the image size, I would assume this is the SQL Server executables that are copied, or SQL Server everything. So these are layers. Each layer adds space or disk usage. So in this, the end of the base image, the Ubuntu one, we have added some files, and they add 72.8 megabytes. That's not much, but down here we add the actual SQL Server product, and that's 1.35 gigabytes. That's a bit more. So how do we build our own? We create the Dockerfile. That's how we build our own images. So let's not start with this very complicated file. Let's take a simpler one. Here we have a quite simple Docker file. We create a file. We either create an image from scratch. I wouldn't do that because there are base images that I would want. And in this case, I want the SQL Server 2022 image as my base. So I start with that. I switch to user root because the SQL Server 2022 image is not running as root, which is very good practice to not run as root. Root is the admin user in Linux. You don't need to be admin to run an application. You wouldn't run SQL Server services as a sysadmin. You would run them with a service account that has exactly the permissions needed to run SQL Server. Same thing applies here. So the SQL Server image runs, or the SQL Server containers will run as the MS SQL user inside the container. But I need to do a couple of steps that requires root privileges. So I'm going to switch to be root, and then I run to MS SQL conf commands. I set header enabled, so HADR, so that I'm able to do availability groups. And I set SQL agent enabled to true. I think this is the only way to enable HADR in a SQL Server container. I don't think there is an environment variable for it. For the SQL agent, there is an environment variable for it, but I want it to be enabled as the default. So I'm customizing the SQL Server 2022 image. These are just simple steps. I'm not adding a lot of space or space at all. So this is all good. But if we look at a Dockerfile where I do some more stuff, I need to install some libraries. So I have a use case where I want to be able to build a Docker container or a Docker container image for a SQL database project, so that when I spin up a new test environment, I can just instantiate the that Docker image and create a container from it, and that container will already contain the database project deployed. So how do you deploy a database project? You do that with SQL package. That's how you deploy a DAC pack, which is the build artifact from a SQL database project. So I've created a Docker file for that. And here I start with SQL Server 2019. I switch to become root. And to be able to run DAC pack, I need quite a few libraries installed. So unzip, lib unwind 8, etc., etc. So I'm doing these installations. I need to add the repository where the DAC pack exists. So I do that here. And this is quite a massive list. And all these steps, they add to the space of the image. So what else do we have? We do install the actual SQL package in the end here. Then we switch to become user MS SQL. And then I add some build arguments. So when I build my image with Docker build, I send in the arguments DB name, password, and the location of the DAC pack. I then copy the DAC pack to the container image. I set some environment variables, and then I run SQL Server. I grep to find from the output, which will be the error log, service broker manager has started. That normally means, okay, SQL Server is up. And then I wait another 15 seconds so that the upgrade steps for the system databases completes. So sleep 15 seconds. Then I run SQL package. So SQL package with the action publish against localhost, because I'm inside the container now. So localhost port 1433 is going to be exposed inside the container, so that's perfectly fine. I connect to it. I set the database name, which I sent in as a parameter. I trust server certificate because by default I'm going to get an encrypted connection, but I don't have a proper certificate, so I'm going to trust whatever I get from SQL. And I have the username and password. And I have the location of my DAC. So I do the DAC deploy. Hopefully it is successful. Then I remove the DAC. And then I kill the SQL Server process. Because remember, this is the build phase to create an image. We're not supposed to leave executables running in the image. There is going to be an entry point for that, which already exists in the base image here. So we don't need to care about it. But if we now go back to my images, I have built this and it's this image. I add quite some steps to it. So we have this, and this is going to be the end result. And let's see where my stuff starts. I think we start around here. We add 56 meg, we add another 48 meg, and then we add SQL package, and we download a big package list. We add 1.78 gigabytes. That's huge. So I'm ending up with a quite large image. And exactly how large is it? If I can only find it again. AdventureWorks 2014. I shouldn't click it. Minus, come on. So it's 3.65 gigabytes. And the image will contain a lot of stuff that I don't need anymore. Because once I have deployed the database, I don't need SQL package. I don't need all those libraries inside my containers that I instantiate from this image. Because all I need is a pre-deployed database in the container that I create from this image. So let's look at how we can make this image a bit smaller, or quite a lot smaller to be fair. So we have this Dockerfile, and the technique I'm going to use is called a multistage build. So we have this from, and when we're down here, we're done. We have an image, but I'm not going to use this image. I'm going to throw it away when everything is all done. So I add another from directive in my Dockerfile. And I'm starting with the same base image. I need to add the arguments, the build arguments that I need for this stage of the build, because from kind of starts over. Yeah. So I add the arguments. I add my environment variables to this one as well. And then I copy some stuff. I copy the AdventureWorks 2014 primary MDF file and the LDF file. And this is going to be the database or the data file names of the database that I have deployed. How do I know? Because I know that that's defined in the SQL database project. So probably you would want build arguments for these as well in a real scenario if you have more than one database to play with. So that would just be arg db data file and arg db log file, stuff like that. But we're hard coding it, but you get the point. So I copied this one from source. What source? Well, it's in the upper from directive. I give it an alias name. So the result of whatever comes when this is done is going to be called src for source. And I can then use that or files from there to copy to the next stage in my build. So I copy those files. I'm not quite done yet though, because now I just have the data files and I need to detach or attach them to this instance, because this is a brand new instance. It doesn't know about this database, so the master database is going to be brand new. So I start SQL Server. And again, grep for service broker manager is started, sleep 15 seconds. I run SQL CMD to run the command exec sb attach db. Database name is going to be my database name. File name 1 is going to be the MDF file, and file name 2 is going to be the LDF file. You could, of course, use attach single file db and just have the MDF. That would work too. And then I kill SQL Server, and then I'm done. So the final image that will be the result from this Dockerfile is just this, plus whatever files I copied from the intermediate or first step in the build process. So I have already built this. We can have a look in here. I built it with the image name AdventureWorks 2014 DB Multistage, and it's just 1.63 gigabytes. So that's a big difference. 3.65 versus 1.63, 2 gigabytes less. And sure, disk is cheap, but if you build as a part of a pipeline or something, you don't want to wait forever, and it takes longer to build a larger image. And when you upload your image to the container registry, well, that's network. And if you use an Azure container registry, it's going to be further away than your printer, for example, in your office room. So it's going to take a while to upload. So keep it tiny as you can. You don't want large containers, because that defeats the purpose of running containers in the first place. I said that I already built these, so how is that done? Well, we do that with a docker build command. And I have an example of how it's done. So let's say we do this first line, docker build. We point to a location that contains a Docker file, a Docker file, which is a file with the file name Dockerfile. We give it a name, so -t for tag, AdventureWorks 2014 DB :2.0. We send in some build arguments, the DB name. These are the ones that I defined in my Docker file. Password. What else have we? We have the location of the DAC pack, and that's it. So running this in a prompt. Let's make this a little bit larger. Well, oh, I need to be in the correct location when I run it. almost code now. So that's the build. And this build didn't do much, to be honest, because I already built it before. And as you can see, you have some cached steps. These are all the layers or the directives that I have put into the Dockerfile. And by default, Docker build is going to use the already existing layers. And it's going to find out if they already exist by creating a hash from the commands in that layer or the directives, and then look to see, do I already have this hash as a layer saved? And it does. If you want to build everything from scratch, sometimes you do, then you would add the argument no cache. I think it's no cache. You can look it up with docker build -- health, and you'll get some arguments. And yeah, it's -- no cache. That would build the image from scratch. And that's going to be, I mean, we could try it. We have it -- no cache, but it would take 10 minutes, and you don't want to wait for it. And it's going to be the same result, it's just going to take a little longer. And the reason it takes a while is this takes a while, this takes a while, this takes a long while, and this, etc., etc. So all these installations of packages take quite a while, but we're going to throw them away anyway. And you see here, this is source step 2 of 7, source step 3 of 7. And then Docker build continues with the target, which is the name I gave to the final step in the Dockerfile. Maybe, just maybe, a good idea would be to actually take this source and create a proper image from it and use that as the base, because then you don't need in your Dockerfile where you just want to deploy your DAC packs, or actually create the final step where you just copy the data files, which are the results from the DAC pack deploy. You don't need to have all the code in that Dockerfile. So if you would have one Dockerfile that creates this DAC pack deploy container image, and then you can use that to actually do your own DAC pack deploys, and then copy the files and then throw away the intermediate steps. That's something you would have in your local repository in your company. You wouldn't push this intermediate step to a public container registry or a semi-public container registry. It's something, it's a tool you will have in your build process when you develop applications, but it's not something that you will publish. So, what have we looked at today? We have looked at a simple Dockerfile, and we have looked at a little bit more complex Dockerfile. And we looked at how we can reduce the size of an image by using a multistage build. So I hope you enjoyed it, and I hope you learned something from it.